These are the answers to homework pages 403 to 405, Unit 12, Lesson 2. Number 1 here was also worked out at the end of the lesson video. So the Venn diagram is completed here. Evens, multiples of 3, they have a share of 6. A, the number in set A is, there's 5 elements. The number in set B is 3. Part B, well, 10 doesn't equal 5 plus 3. Not all elements are in set A or B, and also there's overlap. Number 2, the answer is, well, completing the Venn diagram here, but the answer is 0.34. Number 3, the answer to the question is 0.29. Again, I'll go and work these out. It's page 405, sorry. Page 404. And is going to be the overlapping area, or is your two circles combined. C, everything outside of the and area. D, number 5, the Venn diagram. The answer to 5A, triple I, is 140. 4I is 164. 5B, you had to give the probabilities for all of the starred areas. So you can either have the fraction 24/400ths for this star or asterisk, or the decimal point 0.06, 0.35, or fraction equivalent for the and, the overlapping area, 288/400, or the decimal point 0.57 for this portion of circle C. And this would be 8/400 as a fraction, or the decimal point 0.02. And here's page 405. This is the intersection, the and, right? You're going to have to know that this symbol stands for and, or intersection of. And this symbol here, the U shape, is for union, which is also for or. There we have 4, 5, 6. The complement of A and B would be everything outside of the overlap area. The complement of A or B would be everything outside the two circles. And then the remaining 6. All right, so now I'll go back and explain. So again, if you had no problems, you can just, stop the video, go on to the next assignment. All right, so number 2, I think it may be best to actually work through the problem. Yeah, for the ones that require the Venn diagram. So I suppose for 2, 3, and number 5, I'll actually work through the problems. So certainly if you had no problems, you got number 2 and 3 correct, then just fast forward through the video and go to the problem that you need to see explained. All right, so number 2, take this. So when an animal is selected at random from those at the zoo, the probability that it is American, meaning that its natural habitat is in North American continent, is 0.65. Okay, so American is 0.65. So I'm assuming A must stand for American, yeah. So we'll do a lollipop stick down, 0.65. And the probability that it is both American and a carnivore, so this is American and carnivore, that's the overlap is 0.16. So that would be here, 0.16. So right away, with just those two numbers, I can now figure out what this piece of circle A is, right? So 0.65 minus 0.16. Oh, and here I am. I'm afraid I don't have my calculator in front of me, so, all right, that's 0.49. And the probability that it is neither American nor a carnivore is 0.17. Let's go with this. So neither American nor a carnivore is 0.17. So that means outside here is 0.17. If I draw my OR, that means this here has to be 1 minus 0.17, which is 0.83. So now this plus this plus this would equal 0.83. So if I take 0.83, subtract the 0.49 and the 0.56, oh, I'm sorry, which is the same as 0.65. So if I just subtract the 0.65, I get 13 minus 5 is 8, and 7 minus 6 is 1, 0.18. So this piece is 0.18. The question, well, before I read the question, let me just say, all right, so what is this combined? So this combined is a 0.32, no, 0.34. Calculate the probability that a randomly selected animal is a carnivore. That's it. That's our answer, 0.34. Next, number 3. In a company of 43% of the employees have access to a fax machine. Okay, so I stopped right there. 43% have access to a fax machine. So lollipop stick for F fax machine is 0.43. 38% have access to a fax machine and a scanner. That's the overlapping region. This is 0.38. Same thing. I can stop right here, right? I know this all of circle F is 0.43, and this piece of it is 0.38. So we can find this portion by taking 0.43 and subtracting 0.38. And that leaves us with 0.05. And 24% have access to neither a fax machine nor a scanner. Okay. So that's everything outside of fax machine or scanner. So no fax, no scanner. So outside here, that's 24%. And now the same thing as I did in number 2. That means that this piece here, go with this. The whole thing, both circles together, would have to be equivalent to 1 minus 0.24, which is 0.76. Leaving this whole thing is 0.76, and this whole circle is 0.43. If I subtract that, I get 0.33. So this is 0.33. This portion of circle S is 0.33. Now the question is, calculate. Okay, calculate the probability that a randomly selected employee will not have access to a scanner. All right, so, I should have gotten the total here. I don't have to, but I guess unfortunately I'm going to stay with this color. 0.38 and 0.33 is 0.71. So 0.71% do have access to a scanner. So probability randomly selected employee will not have access to a scanner is 1 minus that. So it would be 1 minus 0.71, which is 0.29. There is another way of there are other ways of getting that, of course. If we're looking for the probability of not access to a scanner, well, we've got, so it would be everything outside of this. So we had the 0.24, and we also had the 0.05 there, right? So that would be outside of circle S. And we just add those two together, and that gives us the 0.24 plus 0.05 gives us the 0.29. Number 4, and is the overlap, or is the two together? Do not have both frequent flyer and checked bags. So both do not have both frequent flyer. So do have both frequent flyer and checked bags is the overlap. So not both of those is everything outside. Have frequent flyer or not checked bag. So frequent flyer or not checked bags. So circle F in addition to everything outside of circle C. Now number 5 I'll also work out. So if you didn't get 2, 3, or 5, but now understand 2 and 3, then you would want to go back to number 5 here and try that if you would for practice. So number 5, for the scenario above, suppose of the 400 people on the flight, 368 have checked bags. All right, so lollipop stick for checked bags. 368. $228 have checked bags but do not have frequent flyer status. So 228 have checked bags but do not have frequent flyer status. So checked bags but not frequent flyer. So that means this piece of circle C. Okay, so I can stop right there. I actually should have made it in purple, but that's okay. So this is 228. I'll leave it. So if all of circle C is 368 and this portion of it is 228, then that leaves how much for this smaller piece? 368 minus 228. I might be able to fit it in here. Is 140. And 8 have neither frequent flyer status nor checked bags. Okay, so that means we have 8 outside. And again, I'll draw my OR this way. So if we have 8 outside, then how many are in the circles combined would be 400 minus 8, which is 392. And I transpose those, 392. Because there was 400 people total. So as if this is 392, all right, all of this together, and we know that this whole circle is 368, then this piece here has to be 392 minus the 368. Which is 24. And then this whole circle will be 24 plus 140. 164. Okay, so who have frequent flyer status and have checked baggage? That's our answer of 140. Who have frequent flyer status? That's our answer of 164. And then fill in the probabilities. So 24 over 400, or 0.06, 140 over 400, or 0.35, 228 over 400, or 0.57, and 8 out of 400, 0.02. And all of these, if I sum them up together, they're all going to add up to 1. And then page 405. Shading set A. Shade A and B, again the notation here, this is for and, looks like the upside down U. Or if you kind of think of it as an N for and, the N in and. A or B. Not in set A, so that's everything outside of set A. Not in A and B, so here's A and B. Not in A and B is everything outside of it. Not in A or B. Excuse me. Everything outside of A or B. Probability of A or B, that's our two circles combined. The probability of B complement, so that's everything outside of circle B. The probability of A and B, that's our overlapping section. The probability of A or B complement, so that means the probability, everything outside of A or B. The probability of A or B, which would be these together, minus the probability of A and B. Take away that. So I think I had it in there, but then I erased it. So you have to subtract that out. And the probability of A and B complement. So the probability of what's in A and not in B. So I want what's in A and also not in B. Yeah, so it would just be this piece right here. It has to be in A, which would be kind of all of this, but also not in B. It's got to, this piece has to come out.